Hey there, folks. Welcome back to Disruptive Concepts, where we explore the coolest tech shaping our future. Today we tackle the topic of soap. Soap is an ancient cleaning agent used for thousands of years. The basic chemistry of soap involves fatty acids and alkalis. Soap molecules have a unique structure with two distinct ends. The hydrophobic end of a soap molecule repels water, but attracts oils and grease. The hydrophilic end of a soap molecule attracts water. When soap is applied to a dirty surface, it targets grease and oil. Soap breaks down grease into smaller, more manageable components. The action of rubbing soap helps lift dirt from surfaces. When you rinse with water, soap molecules help wash away the dirt. The first recorded evidence of soap making dates back to ancient Babylon. In the Roman era, soap was used for both cleaning and medicinal purposes. Modern soap is made through a process called saponification. Saponification involves the reaction of fat with a strong base. Animal fat or vegetable oil can be used to make soap. The discovery of soap-like materials dates back to around 2800 BC. Ancient Egyptians also used a soap-like substance for cleaning. The term soap is derived from Sappho, a Roman legend about Mount Sappho. In the Middle Ages, soap production began to become more refined. The Industrial Revolution brought significant advancements in soap making. Today, soap is an essential household item worldwide. Soap not only cleans, but also plays a role in disease prevention. Hand washing with soap is crucial for maintaining health and hygiene. The chemistry of soap involves an interesting interaction with water molecules. Water alone cannot easily remove oil and grease. Soap creates an emulsion with water, allowing oil to be washed away. The effectiveness of soap depends on its formulation and ingredients. Glycerin is often added to soap to moisturize the skin. Antibacterial soaps contain additional chemicals to kill bacteria. Some soaps are designed specifically for sensitive skin. Bar soaps and liquid soaps are made using slightly different processes. The pH level of soap is typically around 9 to 10. Soap can be made at home using simple ingredients. The use of lye, a strong alkali, is crucial in traditional soap making. Safety precautions are important when handling lye in soap making. The cold process method is a popular way to make soap at home. Soap can be customized with various scents and colors. Essential oils are often added to soap for fragrance and benefits. Soap bars are cured for several weeks to harden and complete the process. The chemistry of soap is a basic topic in many chemistry classes. Soap's ability to clean is a key aspect of its chemistry. Soap molecules act as a bridge between water and oil. The molecular structure of soap is what makes it effective. Soap has played a significant role in public health. The widespread use of soap has helped reduce the spread of diseases. The science of soap is both simple and complex. Understanding soap chemistry can lead to better cleaning practices. Different types of soap are suited for different cleaning tasks. Soap's impact on the environment is a topic of ongoing research. Biodegradable soaps are better for the environment. Some soaps contain microbeads that can harm aquatic life. The use of soap in rivers and lakes should be done cautiously. Soap packaging is also a consideration for environmental impact. The history of soap reflects the evolution of science and society. Soap is an example of how basic chemistry benefits daily life. The molecular dance of soap and water is fascinating. Soap making is both an art and a science. The balance of ingredients in soap determines its quality. Hard water can affect the lathering of soap. Water hardness is caused by minerals like calcium and magnesium. Soft water is more effective for cleaning with soap. Detergents are similar to soap but are made from synthetic materials. Detergents are better at cleaning in hard water. The choice between soap and detergent depends on the application. Soap is more than just a cleaning agent, it's a scientific marvel. The chemistry behind soap is relevant in many scientific fields. Soap is a daily reminder of the practicality of chemistry. The ingredients in soap have evolved over time. Traditional and modern soaps have different characteristics. The process of making soap has remained relatively unchanged. Soap making is a popular DIY project. The versatility of soap is one of its most remarkable features. Soap plays a crucial role in maintaining personal hygiene. The global soap market is a multi-billion-dollar industry. The demand for organic and natural soaps is growing. Soap making has a rich cultural and historical significance. Soap formulations are constantly being improved. The science of soap is interconnected with biology and physics. Soap can act as a catalyst for chemical reactions. The pH of soap is important for skin health. Alkaline soaps can be harsh on the skin. Acidic soaps are less common but have unique applications. Soap's cleaning power is based on basic principles of chemistry. The interaction of soap with skin is a complex chemical process. Soap can remove a wide range of contaminants. The effectiveness of soap in cleaning is universally recognized. Soap has a direct impact on public health and sanitation. The widespread availability of soap is crucial for global health. Soap's role in history is often underestimated. The future of soap may involve new, innovative ingredients. Soap is a simple solution to many cleaning challenges. The balance of hydrophobic and hydrophilic properties is key in soap. The science of soap is both interesting and practical. Soap's ability to emulsify dirt is central to its function. The cleaning process of soap is a type of chemical reaction. Soap has been adapted for various uses over centuries. The environmental impact of soap is a concern in modern times. Eco-friendly soaps are becoming more popular. The production of soap has environmental considerations. Soap is a product that combines ancient wisdom and modern science. Understanding the chemistry of soap enhances its appreciation and use. Thanks for watching Disruptive Concepts.